Hi, everybody. I'm Chris Hoyt. I'm the co-founder and chief financial officer at Upskill. And our mission is to transform hands-on work. So we're an enterprise software company. We develop software to be used on wearables, essentially to help solve real-world problems. I'm going to actually skip to a quick video I have, which I think helps to sort of show a little bit about exactly what we're doing. Oh, well, or not. Let's see. So what you're going to see on the screen here is we have very practical applications of machine learning and AI today, where we build software that allows, in this case, a worker who essentially is doing a job around how do I make sure that this aircraft engine, very similar to what Stefan showed us, is being built correctly, right? That the torque values and that essentially the work he's doing is completely to spec. And what you'll see on the left side is the person doing the job the way they do it today. And on the right-hand side is using our software and using smart glasses to do the same job. And obviously this is sped up because otherwise we would be here for quite a long time. But the primary thing that you see is that we are putting now the information and the intelligence that this person needs to do their job right in front of their eyes, right? So rather than going back and forth to a computer to see what is the next step that I have to do, rather than going back and looking at the computer to see, did I get this torque value to exactly the right setting? All this information is now available straight to that individual. And so what we're really focused on is how do we take, through technology, how do we make the folks that are doing these complex manufacturing jobs more effective, more efficient? Also, safety in a lot of scenarios becomes a very important component. If I'm doing a wiring harness in an engine on a large Boeing aircraft, I don't want to have to come out of that engine in order to look at my computer or look at my paper to do my job. So, everything from how do we do it faster, how do we do it safer, how do we track that compliance, right? So we're tied into, in this case, GE's back-end system, so that now when somebody goes back to see how that engine was built, they can see the specifics, they can see the video of how that was actually done. And so we're taking sort of a very practical approach, and this is technology that exists today. We work with, so General Electric obviously is a customer of ours. We've got a couple other use cases. We have actually 8 different things we do with different GE businesses today. They're also an investor of ours. And we're doing this, let me just make sure I touched a little bit on in total, but we're doing this across a wide variety of industry today. And what gets really interesting is there's some very obvious improvements that we can do in these tasks today. And there's another video, which I won't show, around somebody assembling a wind turbine. And so again, the very complicated manufacturing jobs where each one is a little bit different, right? They have an overall spec, but it's impossible to essentially memorize all the steps that you need to do in this job. So what we're doing is making it easier to get trained both initially for this job, but equally importantly, that training is ongoing, right? So every time I do this process, I'm learning something, and I'm speeding up how I get that done. And again, we believe you'll see on this slide, there's a 34% productivity improvement, and that's measured from the first time this worker uses our software and smart glasses to do their job compared to doing it on their own. So they haven't been acclimated to the technology, and it's nothing sort of particular to our software other than we've spent a lot of time and energy testing this, understanding how people sort of best utilize this information, making sure that it doesn't cause eye strain, headaches, et cetera. But any sort of technology that allows this worker to get access to real-time information is going to be beneficial. Now, where it really starts to kick in is when you now can take, how do we learn from these processes? So now we're getting data from thousands of workers doing the same job or doing similar jobs. And now we can start to see, we all know that some folks are more productive than others in the particular environment they're in. We don't necessarily always know why. But now if we can actually start to measure their performance on subtasks and understand how is that person doing their job slightly differently than the other folks that are doing the same thing, we can provide updates in real time to these workflows to now allow everybody to take advantage of those improvements. And so what we really see here is the ability to invest in the worker with technology, but not displace workers. Because again, a lot of these kinds of things really can't be done by robots alone. They shouldn't be done by robots alone. But if we don't sort of continue to improve productivity, we're not going to have that opportunity to continue to do the kinds of work that we're doing. I'm just going to touch on, so Boeing is also another, talking about flying planes. One of the things that I didn't realize until we spent some time in the Boeing factory is how many hundreds or thousands of miles of wiring go into every plane and how difficult that job is to do. So today, in the environment where they're not using our technology, they've got this pin head, they've got a whole set of pins, they've got wires, they've got a pile of paper that says, here's how to go about doing this job. Person is constantly going back and forth. The ability to have errors is pretty high. And so for a lot of our, so now what we do with smart glasses is all that information is overlaid. So now I know exactly what I'm doing and how I'm doing it. And for a lot of our customers, first-time build quality is as important as any savings they get from productivity. Right? They want to make sure that if I'm building a wiring harness that's going into a plane, that it's built correctly the first time, that I don't have to do rework. And so we're very excited about kind of what we're able to do today, but also very excited about where technology is going to sort of further take this in terms of being able to do predictive analysis in order to be able to improve on these processes. And I guess my primary message is, a lot of things we're talking about are things that are coming. But a lot of these are already here, right? So they're being utilized in relatively small scale because, of course, the Boeings and the GEs rightfully want to make sure that new technology has been vetted. They go through a fairly rigorous pilot process before you put this into deployment. But these are things that are here today. We don't have to wait 5, 10, 15 years to get these benefits. So with that, I'm going to go ahead and turn it over to the next folks. Thank you.